Greetings everyone, welcome to my YouTube channel for Kangaroo Maths and Science Academy. Today guys, I want to take you through trigonometry for part 2. Already we went through part 1 for trigonometry where we started with the grade 11 revision, and also we went through the grade 12 where we used double angles and compound angles. And now I want to take you through the trigonometric graphs. Like I said, guys, that trigonometry usually comes in 3 equations, where the first one is part 1, the one I've addressed in part 1. Kindly, if you have not watched the video for part 1, or if this is your first time watching my video, kindly subscribe, like, and share the video with others. And I believe you will all enjoy. Right, without wasting time, let's now start with the trigonometric graphs. Right, then now, under trigonometric graphs, ladies and gentlemen, first of all, one must be able to understand the standard forms of trigonometric functions. So we just call them the trigonometric graphs. So under trigonometric graphs, we'll just do a summary. You need to understand the following: the trig graphs, the trigonometric graphs. Number one, you need to be able to know the standard form of a trig function. Right, we have standard form of y equals to a sine bx. And also we have that one of y equals to a cos bx. Then after this, I will talk about the one where we actually talk about tan. Right, when you are given a trig function, ladies and gentlemen, you need to be able to understand or know the standard form of those trig function, and also be able to know the components behind that trig function. Then on our trigonometric function for sine and cos, we have this coefficient of sine or this coefficient of cos, which we call it the a. And this, ladies and gentlemen, this a on both sine and cos is called the amplitude. It is called the amplitude. This amplitude actually is there to determine the maximum. It actually determines the maximum, and it's actually there to tell us about the maximum value or the minimum value of the function. So it's there to tell us about the maximum value of a function and also the minimum value of a function. And this amplitude actually, it is there also to determine what you call the range. So we can determine the range of a function by looking at the amplitude for actually both sine and cos. So in other words, what do we mean by a range? A range are just the y values where the function exists. A set of y values where the graph or where the function exists is called the range. Wherever a function or the set of x, y values where the set of x values where the function exists is called the domain. So this amplitude actually, which is the coefficient of sine and also the coefficient of cos, it's called the amplitude. It is there to determine the range, the maximum value, and the minimum value of a function. Then whereas the b, which is the coefficient of x, I apologize, the b, which is the coefficient of x, this b is actually called a period factor. It's called the period factor. So it is the value that is actually affecting the period of a function. So this b actually, we use it to determine the period of a function. And when we are talking about a period as a function, we are referring to the number of degrees or the number of degrees in which the graph will have a full cycle or will have a complete revolution. So that is actually called the period. So actually in mathematics. So how do we actually calculate the period for sine and for cos? When we calculate the period for sine, we use the formula 360 divided by the b, which means this b, it is the value that affects the period, which is the coefficient of x. So to determine the period of a function, we take 360, we divide by the period factor, which is our b there. So this is what is called the period. So now, as I said, we have what you call the amplitude, and also have what you call the period factor. And guys, bear in mind, when we say the b there, it's always the period factor. It is not always that we will say wherever we see b, it will be the period factor. It also depends on the standard form. Because, for example, in the exam, they can give you a function like this, say y equals to b sine ax. So looking at this, you can see that now the b now from this equation, it's now the amplitude. You see, it is now the amplitude. It is now the amplitude of the function. Wherever the a here, it is now a period factor. So do not always think that when you talk about a all the time, we're referring to the amplitude. It depends with where it is. So it's very, very, very important when you are given a function for both grade 11 and 12. This is for both grade 11 and 12. So all the time when we are calculating the period of sine and the period of cos, we always use 360 divided by b. That's why if you remember when we're solving the general solutions, particularly on the video that I made for the general solutions, for cos and sine, we're using a period of 360 degrees. So it's very important that when you are writing your exam, you need to be able to know, look at the standard form of a function, identify the value of a, identify the value of b. Then the society that you'll be able to answer the question. Right, moving on to number 2, we also have a standard form for tan. However, with tan, it's a different case as compared to cos and sine. So when we are dealing with tan, ladies and gentlemen, it's a different case now. So let's write down the standard form for tan. With tan, we have y equals to a tan bx. However, still the a there, it is also, we cannot just, it is just the coefficient of tan, but this, when we are talking about a, it's also the amplitude, but it does not affect, in terms of the tan does not have what you call the maximum value and the minimum value as compared to that one of actually sine. Why? Is because of that. Usually when we have tan, the function for tan along the way, it has what you call the asymptotes. It has what you call the asymptote, where the function or the values of x, where the function does not exist. It's actually where the function is not going to touch. So for example, if we have y equals to tan x, this one has an asymptote where we have 90 degrees and 270. We'll talk about this. So in other words, when we talk about the tan actually do not have a range. So it means we cannot state the range for tan because the functions along the way has amplitude, means it can continue forever. So what does it mean this? It means that now the b here, the b, it's also a period factor. And when we are calculating the period for tan, we use 180 divided by b. So it's 180 divided by b when we are calculating the period for tan. So same applies. Remember, for sine, we use 360, but for tan, we use 180 divided by b. So these are the things that you need to understand when we are given trigonometric functions. Number 1, know the standard form of your function. Number two, be able to identify the amplitude and be able to identify the period factor and be able to know how to calculate the period of that function. So it's very, 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 very important. Then number three, when you are dealing with trigonometric graphs, guys, you need to be able to understand the transformations, because along the way, they actually ask questions that are relating to transformation. And what do we mean by transformation? Transformation, we are referring to translation. We are referring to what is called translation, or we can call it a shifting. So where the graph is actually shifting or translating one point to another, whether vertically or horizontally. And also you need to familiarize yourself with the issue of reflections. And also this is very important for functions and graphs also in paper 1, the shifting and the reflection. It's also important for both grade 11 and grade 12 for paper 1 and paper 2. So all the time, guys, you need to make sure that you understand the standard form of a function. So let us now go deep into the issue of transformation. Particularly, we're going to start with translation. Right. The issue of translation is like, it's just a way where we are moving a function horizontally, either to the right or to the left, or either upwards or downwards. So it's just a way of moving a graph or a function, whether vertically or horizontally. Right, let's talk about this in the context of the issue of, let's say, I'm saying to you, because now we are going to talk about angles now, angles for horizontal. If I say we have something like this, if I say f of x minus k, let's say this is in degrees as the angle. So this means that the graph will shift k degrees to the right. So the graph will shift k degrees to the right because of the minus. But if we have f of x plus k degrees, it means the degrees is the angle. It means the graph will shift k degrees to the left. The graph will shift k degrees to the left in the function. So we know that whatever is shifting to the right or to the left, it's always affecting the x values. It's affecting the x values all the time. So in other ways, it's changing the domain if we were to talk about the context of domain. But if we have, let's say we have f of x plus k is not a degree, it's just a unit. So it means now this k is no longer affecting the x, it's now affecting the y. So which means the graph is going to shift, k units, because now it's not an angle, k units upwards. So if the graph is shifting k units upwards, then the function will be added by k, not inside the brackets, because if it's inside the brackets, will be an angle. However, if we have f of x minus k, then the k as the unit, it means the graph now is going to shift k units. The graph will shift k units downwards. The graph will shift k units downwards. So in other words, whatever the function is shifting vertically up or down, it's always affecting the y values. And something that is affecting the y values has to do with affecting the range. So it's very important for you to be able to understand. This is in the context of translating or shifting. You have also, I believe you also done this also in functions and graphs. We know if a function is shifting to the right, it means it's going to affect the x. So it means on the function we subtract. So if it's shifting to the left, it will still affect the x. On the x, it will be added. But something that is shifting upwards or downwards, it's affecting the function, the y values, in other words. So it's very important to be able to understand the issue of translation, the issue of translation. For example, if we have a function of this form, let's say we are given this function, just an example. Let's say we are given this function. We want to describe the transformation. It can say describe the transformation. We want to describe the transformation. Now, what will be, like, for example, if I say y equals to cos of x minus 45. So if I were to compare this graph with y equals to cos x without the minus 45, I will say it means the graph has shifted. The graph has shifted, because this is now an angle, the graph has shifted 45 degrees to the right. The graph has shifted 45 degrees to the right. So it's very important to understand that. But if I wanted the graph maybe to shift 45 degrees to the right, and also, let's say, 1 unit upwards. You see, now I'm talking about a unit which is upwards. So if it's 1 unit upward, it will now affect the whole function. So without affecting the x, it will be x minus 45 inside the brackets and plus 1 outside. You see that the graph has shifted 1 unit upwards, which will also change the range, or which will also affect the maximum and the minimum value of a function. So in the exam, ladies and gentlemen, when you are given a trigonometric function, you need to be able to know this transformation. It's very important. Whether in grade 11 or whether in grade 12, be able to know the transformation of a function to the right, to the left, which affect the x values, upwards, downwards affect the y values. So it's very important to be able to know this. Without wasting time, ladies and gentlemen, let's move on to the issue of reflection before we start looking at the questions. This is one of the most important things that you need to know when you are dealing with functions and graphs. When you are dealing with functions and graphs, remember, practice makes perfect. Remember, practice makes perfect. Right. I believe you are enjoying. And again, guys, don't forget to like and subscribe, and also hit the bell button for future video notification. Right. Then now, without wasting time, let's now talk about the reflection. We talk about the issue of reflection. Right. Reflection here is the type of the transformation where we are just reflecting either a point about a certain point, or about either the x-axis or about the x-axis. For example, if we have, let's say we have a point here, it's just an example. Let's say we have a point, let's call this point A, and this point has coordinate x and y, and it is in the x-axis. And I'm going to say it is in the first quadrant. So if we have a point of coordinate x and y, this is the x-axis and this is the y-axis. I'm going to say, I apologize, guys. Then one is the y-axis and one is the x. So this is the x and this is the y. So if we do something like we say we have what we call a reflection about the x-axis. We want to reflect a point about the x-axis. What does this mean? When you are reflecting a point about the x-axis, it means the point must pass through the x-axis. So this is about the x-axis. So you see that if we are reflecting about the x-axis, the value of x will not change. So if we have x and y, reflection about the x-axis will not change the x, will only change the y. If the y value was positive, now it will become negative. If it was negative, now it will become positive. So this is reflection about the x-axis. So reflection about the x-axis do not change. What changes? The y-axis. So it's the y value, sorry. Then now the second one is what we call the reflection about the y-axis. reflection about the x. What does it mean? It means we are taking this point, we are reflecting it about the y-axis. So it means the point must pass the y-axis. So you check, do you see that this side, what is it that has changed? It is the x. If the x was positive, now it will become negative, but the y value did not change. So it means now when you are talking about the reflection about the y-axis, what is it that is going to change? It is the x that is going to change. If it was positive, it will now become negative, but the y value is not going to change. So this is called reflection about the y-axis. Then you also have another one which is called reflection about the line y equals to x. What is this line y equals to x? So if I draw my Cartesian plane, so this is the y-axis and this is the x-axis. Then the line y equals to x is this one. It is the one that we actually use when we are determining the inverse of a function. So let's give one example. Let's say the value of x here is 2 and 4. So this is the point here. So if this is our line y equals to x, what does it mean? It means when we say we're reflecting about the line y equals, it means this point must pass through the line to the other point, to the other side. So look what has changed here. Do you see that the value of x, remember the value of x here was 2 and the value of y was 4. But when it comes this side, it means now the value of x now it has become 4 and the value of y now becomes 2. So it means now, what does it mean? It means reflection about the y equals to x, it swap both x and y. So x becomes y and y becomes x. So this is a reflection about the y equals to x. And this is the one that we use actually when we are determining the inverse of a function, where we said when we determine the inverse of the function, we swap the values of x and y. And after swapping the values of x and y, then we make y the subject of the formula. So this is one of the most important things that you need to know when you are dealing with functions and graphs. And another one, we have what you call reflection about the line, y equals to negative x. And what is this? Remember, this is y equals to x, this one. So it means the y equals to negative x will be that other one, that side. So this is y equals to negative x. I believe you are following. So it means with y equals to negative x, what does it mean? It means if we have a point here, let's say this point here, it's x is minus 2 and y is 4. Is this an example? If you are reflecting about this point, look what is going to happen. It means now what was x, it will now become y, because look, the x was minus 2 and the y was 4, which means this time around, the x now will be, however, you see now the x will, instead of being 4, it will now become negative 4, and the y values now will become 2. What does this mean? It means when we are reflecting the point of x and y, then those values, x become y and y becomes x, but both of them changes sign, becomes negative. So that is what you need to understand. So it means when we have 2 and 4, we want to reflect about the line y equals to x, then the x and the y, the x becomes the y and the y becomes x. So we have 4 and 2, but both becomes negative. Both become negative. That's why here we had 4, minus 4 and 2. Why? Because it's because we have minus 2 and 4. This is the x, this is the y. Then we swap. So it means the y becomes 4, I mean the x becomes 4 and the y becomes negative 2. Then you have to apply negative sign on both sides. This becomes minus 4 and 2. So this is called reflection about the line y equals to x. Remember, this is also important when you are dealing with functions and graphs. This is very, very, very important when you are dealing with functions and graphs. And in some instances, you find that if you are not, let's say, for example, you are having the reflection about the x-axis. In the equation, if you have reflection about the x, it means you have something like this. It will be minus f of x. What does it mean? It means that the x did not change. What it has changed is the whole equation. It's y. So it means the y has changed. This is a reflection about the x-axis. But the reflection about the y-axis means the y did not change. What it has changed is the x. It means the x is the one that becomes negative. So this is the reflection about the y-axis. So it's very important when you're given a function, you need to be able to explain their transformation. For example, if you have, let's say you are given a function of this form. Let's say you are given this form where you have, okay, y equals to minus sine x. Because of this, look, the x is positive, but the function here there's a minus. What does this mean? It means this is a reflection about the x-axis. Why? Because the x does not change. What is changing is the y. So this is actually a reflection about the x-axis. But when we have this, let's say you have y equals to sine into negative x. What is it that it has been affected? It is the x. The x is being affected by the minus. So it means this is a reflection about the y-axis. Why y-axis? The y-axis, y does not change. What is going to change is the x. So it's very important for you to be able to know these transformations. Very, 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 very important. When you are dealing with trigonometric graphs, be able to know the standard form of a function, be able to identify the amplitude if it's a sine or a cos, be able to identify the period factor of a function, be able to sketch the graph in most of the cases. And even if the graph is being sketched, you must be able to get the values. So it's very important to know the standard form of a function. Then the other things is just the issue of shifting, where the graph is shifting to the right, shifting to the left, upwards, downwards. Determine the equation of what if the graph is shifted about the y-axis, about the x-axis. These are exam typical questions. Once you understand this, you are not going to, you are going to get the correct. You're going to pass actually. Let me just say you're going to pass. So practice makes perfect. Practice makes perfect. Now, since now we went through all the things that you need to know when you are dealing with trigonometric graphs, let's deep dive into the example. Let's just deep dive into the example together to check to check whether you understand or not. Remember, if you do not understand, kindly pause the video, analyze it. If you don't understand, reach out to me, make a comment in the YouTube, in my YouTube channel, and please don't forget to like, subscribe, and share the video. All right, now let us move on to let me now try to share. Let me stop the sharing now. Okay. I believe you guys are following. Okay, now let's deep dive into the question. Now, bear in mind, guys, those who are in grade, remember this for both the grade 11 and 12, but I'm going to deviate a bit to accommodate almost everyone. Remember, when you are in grade 11, we do not have things like double angles and compound angles. So it means I'm going to use different methods in assisting everyone to understand what I want to address here. All right, let us go through the question one by one. Right, the first function, it says f of x equals to sine 2x. F of x equals to sine 2x. So we're given the function of f, which is y equals to sine 2x. And we are also given the function of g, which is equals to y equals to cos 2x. Now, before we start solving the equation, let's now analyze our function. Let's start with this one. Remember, we are using sine and cos. Now, what is the amplitude here? And what is the period factor? So I'll just pause the video. I'll just give you some minutes just for you to get me the period and the amplitude and the period factor, just to check your level of understanding. So I'll just give you a few seconds. Then from there, I'll tell you what is the answer. Okay, I believe you got the answer. We're going to start with the first one by looking at sine 2x. The coefficient of sine is actually 1. So the coefficient of sine is 1, and the coefficient of x is 2, which means there we have the amplitude is 1, and the period factor is 2. Then this one, the amplitude is 1, and the period factor is 1. So it means that within the function of f, we can be able to know what is the minimum value and what is the maximum value of this graph. So we can be able to know what is the minimum value, where the graph is going to turn at the minimum, and what is the maximum value of the graph. But since we know the amplitude, it means the minimum is -1 and the maximum is 1. So this is the one that determines the range. Same applies with the G, also has an amplitude of 1. It means to have the same minimum and the maximum. Right, then the first question says, write down the period of G. We want to write down the period of F, or I mean to say, it wants us to determine the period of F. And how do we determine the period of F, guys? To determine the period of F, we take, because it's a sine, we take 360, we divide by the B factor. And what is our B factor? The B factor is 2, so which means the period of F is 180 degrees. The period of F is 180 degrees. Then now, what would be the period of G? The period of G, same applies for using sine. It will be 360 divided by the B factor. And what is the B factor? The B factor is 1, which means this one completes a full cycle after 360 degrees. After 360 degrees. So we have answered the first question. So the period is 180 and 360 degrees for F and for G respectively. So we now know the period of the function. Remember, practice makes perfect. Then 1.2, it says, now write down the range of F and the range of G. We want to know what is the range of F and also what is the range of G. Like I said, guys, the amplitude on sine and cos is the one that determines the minimum value and the maximum value, which is used to determine the range. So it means the range of F and range of G is the same. The range of F is, we look from considering, including from -1 as the minimum to 1. It means the graph of this, when you're going to sketch it, the minimum will be -1 and the maximum will be 1. So this is the range of F. Or if you do not want to write like this, we're going to say y is between -1 and 1, inclusive, where y is an element of real number. Y is an element of real number. So this is the range of the range between -1 and 1. Remember, -1 is the minimum value and 1 is the maximum value. So same applies with the G. G also has an amplitude of 1. It means it will have the same range from -1 to 1 inclusive, which means -1 and 1 are also included. So this is our answer. We have now answered the question number 2. So remember, this is just the basics, but they're very important for you to know, because even in grade 12 or in grade 11, they can ask you this. So it's very, very, very important for you to be able to answer the questions. Now we got the period of F it's 180, G it's 360. We now know the range of the function that when we want to sketch those two graphs, they will range between -1 and 1. -1 being the minimum or the lowest point, 1 will be the highest point. So this is very, very, very important when you are dealing with the graph of when I'm dealing with trigonometric functions. But guys, how about if we had, let's say, just an example, y equals to half, let's say y equals to half tan 3x. What would be the a here? The a will be half. However, we know that when we're dealing with tan does not have a minimum and maximum in terms of determining the range. Then how about the period factor? The period factor is 3. But what would be the period of this? Remember, when we're dealing with tan, we use the period of 180 divided by b, so which will be 180 divided by 3. It means the period of this graph will be 60 degrees. 60 degrees will be the period of the function. So it's very important, ladies and gentlemen, to understand what you're actually doing. Remember, practice makes perfect. Practice makes perfect. So that is the period of the function. 180 divided by 3, and that will give us a period of 60 degrees. It's not part of the question, I'm just adding it so that when you practice, you are able to understand. Right. Now we have answered the first question and the second question. Now we can move on to the third question. But before moving on to the third question, guys, I wanted to us to first answer 1.4 because there's something that I wanted to show you here. I wanted us to answer question 1.4 before sketching the graph of 1.3. Right, let me erase some of the things to create space. Now I hope you're following, guys. Practice makes perfect. Practice makes perfect. Okay. Without wasting time, let me erase this then so that we move on. Okay, so if you feel like you do not understand what I just said, kindly text me on in my YouTube videos. Just make a comment there, then I will attend to you as soon as possible. All right. So we went through the first question. Now I wanted us to do this. I want us to say to have answered 1, 2. Now I want us to go through question 1.3 because 1.3 says on the same set of x's sketch the graph of f and g from 0 to 90, where x is an element between 0. It means this is the domain. We're actually given a domain. It means we need to sketch the graph from 0 to 360 degrees. Please, guys, before we sketch the graph, let's now answer 1.4. Let's now answer 1.4 because there are some other things that I want us to look at when we're going to sketch the graph on question 1.3. It says that you are given f of x, which is equals to f of x, which is equals to sine 2x. Determine the x coordinate of the point of intersection of f and g. We want to know the x coordinates of the point of intersection of f and g. What do we mean by the point of intersection? Where we have the point of intersection, it means it is the point where the graphs are equal, point of intersection. So when we have a point of intersection, it means it is the point where the two graphs intersect, and it is the point where the two graphs are actually equal. It is the point where the two graphs are equal. So in other words, we want to know the x coordinates of the point of intersection of f and g. Now we're going to say f of x equals to g of x. Now, ladies and gentlemen, if we are just given this expression, it means we want to know the values of x. which will be between 0 and 360. Why between 0 and 360? Is because remember the first question says sketch the graph from 0 to 360. Means wherever we want to know the values of x where the two graphs are equal between 0 and 360. So it means you have to solve for values of x, but these values of x must be between 0 and 360 degrees, which means this has to do with the issue of general solutions. Kindly, guys, if this is your first time watching my video, you can kindly subscribe and also check the video for the general solution. Then, I mean, if you are getting confused here, go through the video of the general solutions. But it means what you're going to do, you're going to say, okay, we have sine 2x. Okay, let me just use, okay, it's fine. We have sine 2x. Okay, let me use it's okay. Okay, let's just continue. So we have sine x, and this sine 2x is the function. So we're given sine 2x is our f of x. We want to equate it with g of x, which is cos x. Right, ladies and gentlemen, I want you to listen to me very well. Because this video is for both grade 11 and 12. Learners who are in grade 11, for them to solve this equation here, they have to use something like something called co-function. It means we need to use co-functions in order to solve this question. So the co-functions, if we use co-function, then we'll be able to solve this question. Okay, guys, I want to create a very a space where we can write this nicely, because I want to show two methods to accommodate both grade 11 and grade 12. It's easier for grade 12 to solve this, but even the grade 11, you need to know it. So what I'm going to do is I'll say, okay, fine. Let me just get a space where we can, yeah, it's here. Let's just solve now. We were busy with 1.4. I just want to have, okay, let me just use the red one. So it means now we'll say on 1.4, we're talking about the values of x where f of x equals to g of x, but the values of x should be between 0 and 360 degrees. So what is our f of x? Our f of x is sine 2x. And what is our g of x? Our g of x is cos x. So what I'm talking about is we can change this using co-functions. What do you mean by co-functions? Co-functions are those ratios that are changing when we are using 90 and 270. Okay, for example, if I say I have sine of 90 minus an angle. 90 minus an angle is in the first quadrant according to the reduction formula, where sine is positive, but because of 90 it becomes cos. Or if we have cos of 90 minus an angle, this becomes sine x. So this is actually called a co-function. So it means what we can do here from there, we can either change sine to remain with cos only, or we can either change cos to remain with sine only. So, but in terms of here, I'm suggesting that let's change sine to remain with cos. Why? Because now it's easier to use the general solution for cos, because cos allows plus and minus. Remember we said when we are determining the general solution for sine, how many answers are we supposed to get? Supposed to get two answers. The first answer and 180 minus the first one. So you can also use that. But when you're using cos, we allow plus and minus. So what I'm going to do, I'm going to say, okay, fine. Since I want to change sine and remain with cos, let's start with this one. We say cos x equals to sine 2x. I hope you are following. So it's what I've done, I started with this expression this side. So now I want to remain with cos, which means I have to change the sign using a co-function. Just to do that, you're going to say cos into 90 minus 2x. Let's confirm that. 90 minus an angle is in the first quadrant. where cos is positive. But because of 90, the cos will change and become sine. So this is our choice. I have changed the sine to become cos. So it means you can change cos to become sine. There is no problem. Then now, let us now solve the answers. Remember, the angle that we have changed to cofunction, the angle that we have changed to cofunction, the angle that we have changed to cofunction, it will be our reference angle. So it will be our reference angle. So what does it mean? It means that we know that when we are dealing with cos, remember we said if cos of an angle is equals to A. When we want to calculate the angle of A, we allow plus and minus the second function cos of A plus K times 360. What is this A? A is actually our reference angle. So this is what we're going to do. We're going to say, okay, fine. Since we have both cos, we're going to say x equals to, we're going to say x equals to plus or minus. Why are we doing this? We're using the general solution for cos, which is 90 minus 2x plus k times 360 when k is an element of integers. So to expand this, we're going to say we have x equals to, we start dealing with the plus 1. Plus into that, this will give us 90 minus 2x plus k times 360 when k is an element of integers. The second one, now we're going to say x equals to, we now multiply everything by negative. So negative times 90 will be negative 90. Negative times positive, negative 2, that will be positive 2x plus k times 360 when k is an element of integers. Remember, if we were to determine general solutions, we're going to have two answers. So let us solve for x. To solve for x on this expression, we're going to group the like terms. And grouping the like terms, it means first we'll transpose the minus 2 to the right-hand side. This will be x plus 2x, which is actually will be 3x. I believe you guys are following. Let me just shortcut. So x plus 3x, then this gives us a value of, I'm saying x plus 2x, then this is 3x. So it's 3x equals to 90 plus k times 360 when k is an element of integers. Then the second one, what is the second one? Second one, we transpose the minus 2 to the right-hand side. This will be x minus 2x. This will give us minus x equals to minus 90, if I'm not mistaken, plus k times 360 when k is an element of integers. So let us now divide everything by 3. Dividing by 3, okay, guys, let me, I'm coming. Just okay, guys, I apologize. Guys. Okay, let me pause here. Right, then now, dividing by 3 on the first expression, remember this is 1 and this is 2. Let's divide by 3. Remember, it will also affect the period. So it's going to be 9 divided by 3 is 30 plus k times 360 divided by 3. This will give us a period of 120 when k is an element of integers. Then the second one, we have to multiply by negative. Remember, this multiplying will not affect the period. So it will be 90 plus k times 360 when k is an element of integer. So we change the ratio. We change the ratio from sine to cos using cofunction. This is also applicable to grade 11 students. So make sure you understand this. But guys, the question did not say determine the general solution. The question wants the values of x that are between 0 and 36. So we need to generate that. And now we're going to generate that. We now consider this k an element of integers. So it's very important to write the notations where you say k is an element of integers. So it means when we say k, then it means we are saying this k is numbers that are negative or positive, integers actually. So what we're going to do, we're going to say, okay, when k equals to 2, usually we start with 2. When k equals to 2, and when k equals to 1, when k equals to 0, when k equals to -1, and when k equals to -2. Actually, we're going to stop at 2, but however, it will not give us the answer. So we want to know the values of x that are between 0 and 3. If they're not falling there, we're not going to accept them. Now, how are we going to do that? It means where there is k here, we substitute the k by 2. So it means we're going to say when k is 2, 2 times 120, 2 multiplied by 120 is 240. And 240, when we add with this 3, so it's, I'm saying 30 plus the 240 that we got here. So 2 multiplied by 120 is 240. So 30 plus 240 is giving us 270. And 270 it is in the interval, so it means it's the correct answer. We take it. It's 270. It's part of the interval. We take it. Let's now substitute by 2 in the second equation. 2 multiplied by 360. 2 multiplied by 360 is 720. You see, 720 plus 90 is a bigger angle. So it's out of the interval. We're not going to use it. So we're not going to consider that. Let's now substitute by 1. 1 multiplied by k. 1 multiplied by 120 is 120, and 120 plus 30, this will give us 150 degrees. So 150 degrees is the correct one. It is the correct one, ladies and gentlemen. It is the correct one. Let's now put 1 in the second expression. 1 multiplied by 360 is 360. 360 plus 90 is a bigger angle. We're not going to take it. Let's now substitute by 0. 0 multiplied by 120, it's 0. And 0 plus 30, the answer becomes 30. This is the answer. And again, 0 multiplied by 360 is 0 plus 90, it's 90. You see, these values, they're following between 0 and 360. So now, but if you use -1, the answer now will become negative. You can confirm it. It will now become negative. So it means, what are the correct values of x? The correct values of x is a set. We write there's a set. It's a set from, what is the minimum? 30, followed by 90, followed by 150, and followed by 270 degrees. And guys, what does this mean? It means that when we're going to sketch the graph of f and g, they will intersect at 30 degrees, they will intersect at 90 degrees, and they will intersect at 150. Lastly, they will intersect at 270 degrees. That is the point of intersection of those graphs. But now we used cofunction. We use the cofunction where we change cos, sine to be cos. But those who are in grade 12, ladies and gentlemen, you can also use another approach. Why? Because look at this. Sine 2x, to you, you know this is a double angle. It is a double angle. It is a double angle. And since it is a double angle, what can we do? We can expand it, ladies and gentlemen. We can expand it. So kindly go through this equation, right? Then wherever you don't understand, kindly reach out to me. So I wanted to accommodate those who are in grade 12. They can either use cofunctions, or they can either use the double angle, right? For the grade, okay, for the grade 12 learners, it means here they will have to do this. I'm not gonna erase, I'll just try to accommodate everyone. So this means this is for the grade 12 only. Grade 11s, this is not yours, guys, because you guys are not doing the double angles. So it means in terms of grade 12, it means you're gonna say sine 2x equals to cos x. Then we change sine 2x to have, is a double angle, is 2 sine x cos x. Then we transpose cos x to the left-hand side. This will be minus cos x divided by 0. We do not have to divide by cos, because when you divide by cos, we'll reduce some of the solutions. So to avoid that, we do not have to divide by cos. What is the common factor? The common factor is cos x. We are taking a common factor. We're going to remain with 2 sine x minus 1 equals to 0. Then it means cos x equals to 0. Or then 2 sine x minus 1 equals to 0, which is just sine x equals to half. I believe you are following here. Then we know cos in terms of general solution, it must have how many answers? It must have 2 solutions. So it means here we are going to say x is plus or minus. Then we say second function cos of 0. This will give us plus minus 90. Plus minus 90 plus k times 360 when k is an element of integers. Or what are the solution for sine? Sine always have 2 solutions if you want to determine the general solution. The first answer and 180 minus the first answer. Second function, sine of half, this will give us 30. So it will give us 30 plus k times 360 when k is an element of integers. What is the second one? 180 minus the first one. So 180 minus 30, it will give us 150 degrees plus k times 360, k an element of integers. You see that you have 30 there, we have 150, we have 90, and actually with this, if it's a negative angle, we can just take that negative angle, we add it by the period of 360. So negative 90 plus 360 will give us 270. You see already we have those. We have 30, we have 30, we have 150, we have 90, we have 270 is also there. You can also use the k values to do that. The answer will still be the same. Remember, there are many ways to skin a cat. There are many ways to skin a cat. Remember, practice makes perfect. So it means when you're going to sketch the graph of f and g, we will see that they're going to intersect at 30, they're going to intersect at 90, they will intersect at 150, and they will also intersect at 270 degrees. It's very important. It is very, 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 very important. Right, without wasting time, let us now go back to our working. Now we got the value of x. So, okay, let me now erase these guys. You can write them down because you're going to use them. X is 30, 90, 150, and 270. So it means what? The graph that we're going to sketch, the graph will intersect at 4 points. They will intersect at 4 points. So it's very important to know that. It is very, very important to know that. Okay? Right, okay. I apologize. Let me share the... Stop sharing. Okay, I think I've selected the wrong paper. Okay, there it is. So now we've answered the 1.4. We have answered 1.4. Now we're gonna move on to 1.3. 1.3 says on the same set of axes, sketch the graph of f and g, where x is an element between 0 and 360, where x is an element between 0 and 360. So we can actually sketch the graph here. I think it will be visible. I believe it will be visible because I wanted us to, okay. No, it's fine. Let's just create a space this side, then we'll come to that one. Okay, it is our, okay, now we want to sketch. Let's sketch the graph. By the way, before we sketch the graph, remember we're not given any graph paper. So it means we have to create our own scale. And how to do that? It's easy. Let me show you how to do that. Okay, this is our y-axis. Okay, this is our y-axis, ladies and gentlemen. Okay, with the, let's say, the x-axis. It's not drawn to scale. Okay, I believe you are following. Okay. Oh, okay. Let me just try to change it. Okay. Just from here. It's okay. Okay, let's just leave it, guys. Let's just leave it and sketch the graph. Okay, there it is. So this is our 0. point, the maximum it's 1, and the minimum it's minus. I just want to make the graph too big. Right, then now look at this. What is the period of f? We got one graph has a period of 180 and the other graph has a period of 360. To get the step size, let's take those periods and divide by 4. 180 divided by 4 will give us a step size of 45. It means this one gives us step size of 45. Then 360 divided by 4, this one will give us a step size of 90. So what does it mean? It means we need to increase the angle by the smallest value there, which means you have to increase the angle by 45, because if you increase by 45, we'll get 90 along the way. So we have 45 plus 90, 45 plus 90, then 90 plus 45, it's 135. So we increase by 45, plus 45 will give us 180. Plus 45 will be 225. Remember, we want to sketch up until 360 degrees. Plus 45, it will be 270 degrees. Plus 45 will be 270 plus 45, that will be 350 degrees. I apologize. Then plus 45, it will be 360 degrees. Then we need to sketch the graph for both sine and cos. I'm going to say yes, the sine is sine 2x, and the cos is, the g is cos x, if I'm not mistaken. Right, let's do this. To sketch the graph, we are going to use our Casio. So I'm going to say you go to mode. You go to mode. After mode, you go to table. There's a function called table. Mode, table, I think it will be number, it depends with the calculator. Some is number 7, some is number 3. Then we put the function. What is the function? The function is, let's start with sine. Sine 2 alpha close brackets. Then now we will sketch the graph. Okay, guys, just a minute. Okay, guys, we can now continue. I apologize. Right, then now, as I was saying that you go to mode, after mode, then you go to table, then you insert your function. So be careful. Then you must say sine 2. Let's start with the sine 2x first, this one. So you're gonna say sine in the function, then you press 2, then the x is on the closed brackets. So it means you must say alpha. You press the alpha button, then you press the close bracket, then the x will appear there. Then now you're gonna press equals to, then equals to, some of the calculator it will show a g of x, but some will just show the start. Then you just press equals to, then the start will be the starting point. We want to sketch the graph from 0. So the start is going to be 0. So it's going to set 0 there. The end will be 360 degrees. We want to end at 360 degrees. Then what is the step? The step is by what degree we want to increase the angle. The step size will be 45. So you want to press 45. Remember, you do not have to do this in the exam because usually they give you a graph paper. So you're going to say when x is 0, y is also 0. When x is, I'm going to say not 0, not 1. I apologize. When x is 0, y is also 0. It means the graph will be at this point. When x is 45, the y value is 1. When x is 90, the y value is 0. When x is 135, the y value is -1. When x is 180, the y value is 0. Just like that. Then 225, maximum is 1. Then 270, 0. 315, -1, and 360. So it means the graph will look like this. So this is our graph. the graph will look like this. So we're going to have the graph of f. So I apologize, we're going to have the graph of f. So the graph will look like this. The graph will look like this. Remember, practice makes perfect. So the graph will actually look like this. Right, I believe you are following. Then now, let's call this the graph of f. Now I'm going to use a different color. Now we sketch that one for cos. So we do the same cos alpha, close brackets, then the x will appear. Then the start is 0, the end is 360, step is 45. Same applies. And let me use a different color so that you are able to see what I'm actually doing here. So when x is 0, when x is 0, then the y is 1. It says the y is 1 there. When x is 45, it says the 1 is roughly 0.7. Let's assume it's 0.7 something. So it means they will intersect somewhere there. Then when x is 90, then the y is 0. Then when x is 35, the y becomes negative 0.7. So let's assume somewhere there it's negative 0.7. So it means the graph will be somewhere there. They will meet at that point. So 180, it says negative 1. It means the point will be there. Then 225, it says back to negative 0.7. So it means it will be there. And then 270 is 0. Then now coming to 315. What is 315? 315 is 0.7. So it will be somewhere here. It will be 0.7 somewhere there, if I'm not mistaken. Then lastly, 360, then the answer becomes 1 at the highest point there. So it means the graph will look like this. Let's sketch the graph. The graph will look like this. The graph will pass there and pass there, and it will pass there. The graph will pass there up until that side. So this is our function. Now, I want us to look at the graph and let's check where the graphs are intersecting. Let's kindly look at the graph where these two graphs are intersecting. So this is our G. You see that by looking at the graph intersects at 4 points. The graph actually intersects at 4 points. And since the graph is intersecting at 4 points, we already solved the x coordinates of where the two graphs are actually intersecting. The first one, when I'm not wrong, we got the value of 30. You see, this is the 30 here. This is the 30. So this is our 30 here. This is the 30 degrees angle. So let me use a different color. This is our 30 degrees angle. Right. So we're gonna have, okay, let me just use, we're gonna have 30 degrees here. So this is our 30 degrees. Another one, it is at 90. We got it. Another one, it is the one at 150 degrees. We got that 150 degrees. I believe you guys are following. 150 degrees. Then the other one is at 270. At 270. How many points? 4 points. 270 degrees, 150 degrees, 90 degrees, and the 30. We got that we have shown that the two graphs are actually intersecting at 4 points, algebraically so. So it's very important to understand what you're actually doing. All right. Now we have sketched the graph. And guys, make sure that when they say sketch the graph, look at the domain. If they say sketch the graph from 0 to 360, you must sketch the graph from 0 to 360. Do not sketch the graph beyond that because you'll be penalized. You'll be penalized. So make sure you sketch the graph up until based on your domain. So it's very important. So you can see that from the graph, this graph has the highest point of 1 and the minimum point of -1. This is the one that is telling us about the range and the domain. So I believe, guys, you are following. Right, I do not want to discuss this graph. I want us to go up so that we will come back to these questions, so that we use this graph in answering the questions. I don't want to, okay. So let me just take it up. Okay, there it is. By the way, we have answered 1.4, which says If given f of x, then okay, fine. Then before that, let's now answer 1.5. I don't want to discard this graph. It says write down the equation of h. So I want to answer 1.5. Write down the equation of h. We want to write down the equation of h. This h, which resulted after shifting the graph of g, By the way, what is the graph of g? The graph of g, if I'm not mistaken, is cos of x. So we're actually writing and we want to determine the new equation of h by which resulted after shifting the graph of g, 30 degrees to the left. We know any function that is shifting to the left always affect the x. And also 2 units upwards. So it means this one affect the y. So how are we going to write the equation? It means we're going to say h of x will be, then we write cos. So remember, the 30 degrees affect the x. So we're going to write x here. Then now how many degrees? 30 degrees, which is our k, the k angle, which left. So if it's a left, it means we have to write a plus. So it's going to be plus 30, which represents that the graph will shift 30 degrees to the left. Outside, then you're going to write plus 2. Why plus 2? The graph is going to shift 2 units upwards. So upwards, we write it outside the brackets. So this is the equation of h. So the h will have this equation, cos of x plus 30 plus 2. So that is our equation of h. I believe you are following. Plus 30 and plus 2. So this is the answer for 1.5, I believe. Because if it was to the left, to the right, here we're going to have a minus. So you need to understand. Downwards, it's negative. So it's what you need to know, guys. So we got the equation of h. Let me write it here. The equation of h, it's cos into x plus 30 degrees plus 2 plus 30 degrees plus 2. So that is the equation of h. Now we got the equation of h. Let's now move on. I'm not going to erase anything, guys. Okay, let me just reduce some of the things here. Okay, right. Then 1.6 says, now do what? Determine the range of h. We want to determine the range of the h that we got now. We want to determine the range of this h, ladies and gentlemen. How are we going to do that? Remember, the graph that is shifting upwards or downwards always affect the what? The y values, like what I said. So before we start analyzing this, what was the range of g? What was the range of g? Remember, the g has an amplitude of 1, which means the range of g was from minus 1 and 1. And you can also read from the graph, from this graph, the minimum is minus 1, the maximum is 1. So, but look at this, the graph now, if the graph now is going to shift 1 unit up, it means any point from minus 1 to go to what? To 1, because to move from minus 1 to 0, 0 to 1. So how are we going to calculate the range of h? What we do? We look at the amplitude, I'm saying the minimum of g and of g. What is the minimum of g and the maximum of g? It's minus 1 and 1, which means you're going to add both sides by these 2, because we're moving upwards. So it's going to be minus 1 plus 2 and 1 plus 2. So we add by 2 both sides. So the range will be from 1 up until 3. So this is the range of the graph. The range of the graph will be 1 and 3, because the graph is going to shift 2 units upwards. So all the points will shift 2 units upwards. So it means if the minimum was minus 1, it will move from minus 1 to 0, 0 to 1. That's why it will have the minimum of 1. Then from the one with the maximum of 1 to move from 1 to 2 to 3. So it means this is the range of h. So you need to understand that. If this was shifting downwards, instead of adding, we're not going to add, we're going to subtract. So it's very important to be able to know these transformations. It's very important to know the transformation. So without wasting time, let's now move on to the next question. Okay, we now got the range. It's from 1 to 3. I believe now you're following. Right, then now let's now continue. Let me erase this. I hope now you understand how we got the range of graph of f. The range is affected by x, not by y. Okay, 1.7 it says, write down the equation of h. Write down the equation of h. We want to write down the equation of h resulted after what? After reflecting the graph of f. The h is an equation which resulted after reflecting the graph of f about the x-axis. So we reflect this graph of f about the x-axis, number one. And after a what? A shift of 1 unit downwards. So it means we perform a reflection about the x-axis first, then thereafter we shift the graph 1 unit downwards. How are we going to do that? So it means, what is our f? Our f is y equals to sine 2x. Now let's perform the first transformation. The first transformation says we have to reflect the graph about the x-axis. And what did I say about the x-axis? About the x-axis, x does not change. What changes is the y. So we go to our function and say, okay, there we have x, and there we have x. Means we have y. Since the y is positive, now we have to change it and let it to be negative. And by the way, we cannot leave the equation like this. We have to multiply both sides by the negative sign. I believe you guys are following. So it means the equation will be y equals to minus sine 2x. This is a reflection about the x-axis. Why? The x does not change. What changes the y? I believe you are following. Then again, it has to shift how many units? 1 unit downwards. So it means it will be outside. So it's going to be minus 1. So it's 1 unit downwards. So we have reflected the graph, 1 unit, the graph about the x-axis. Then thereafter we shifted the graph 1 unit downwards. So this is what they wanted us to do. First we do reflection, secondly we shift the graph 1 unit downwards. So it means this will be the equation of w of x. So it means w of x is minus sine 2x minus 1. So this is our w of x. So we got the equation of w of x. I believe, guys, you are following. I believe you are following. Now, let us move on because I do not want to erase anything from the graph because we have to use the graph to answer some of the questions that follows. Okay, let's start with the first one. Okay, let's do this. First of all, they want us to know where f of x equals to g of x. And secondly, they say use the sketch the graph in question 1.3. We use the sketch the graph in question 1.3 to determine the values of x for which f of x is greater or equals to 0. Okay, let me do this because I wanted to us to write these values somewhere. Okay, let me take a snapshot of this so that I'm able to write them. Okay, now let's now go straight to our graph, the graph that we have sketched here. Yes, this is our graph. Number one, guys, it says, number one, we need to use the graph to determine the value of x. We use the graph to determine the value of x where f of x, that is number one, where f of x, let me just write this, where f of x is greater or equals to g. Where f of x is greater or equals to g. What does this mean? We want to know the value of x where the graph of f is above. It's either above or equal, because there's an equal sign there, equal to g. So it means we need to read from the graph where f is above g or equals to g. Wherever f is above g or equals to g, that's where we want the answer. So let us now go through our graph. Right, looking at the graph, let's look. Remember we said the graph of this color? The graph of this color, it's our g. And the one in blue, it is our F. I hope you understand. Right, when we say one graph is bigger than the other, it is the point where one graph is actually at the top. So if one graph is at the top of the other, so we say this graph is bigger than this. So it's what I will be talking about now. So let's go through this. How are we going to do that? Actually, we need to look where the graph are equal, because it says either the greater or equal, greater or equal. Okay, let me use a red color so that you can be able to understand. Look, from this point here, it is at 30. Let's check. Before 30, the graph of G from here to here, this is G, this is F. What does this mean? It means G is bigger than F. It's not what we want. But now let's move from 30 up until 90. Yeah. Check. From 30 up until 90, the F is above. So this is the F. The F, it's above G. So it is where we want. So this is the point where F is bigger than G. Okay. Now, when we move from 90 to 150, G is bigger than F. Is not what we want. But from 150 up until 270, F is above G. So it means this is where we want. This is where we have to look for the answer. But above 270, G it's above F, which means this is the point where G is bigger than F. It's not what we want. But since here we said we want where the graph of F is either above or equals to. So it means we need to include the point where the two graphs are actually equal. So how many points did we, how many areas did we get here? Is this part here and this part. So we're going to say the answer is from inclusive, from the minimum as the 30, from 30, here's the 30, from 30 to 90 degrees. We're including both 30 and 90 because they are equal at that point. So from 30 to 90, it's where the two graphs are either bigger or equals to. Or again, from, what is another point where they're equal? 150, from 150 straight to 270 degrees. So this is our answer. This is our answer. We can also express this in terms of x. We can also say x is between 30 and 90, or x is between 150 inclusive and 270. It's also applicable. You can also do it like this. So it means this is the point where the two graphs are either equal or F is bigger than G. So it's either F is greater or equals to G or equals to G. Very important. Greater or equals to G or equals to G. Very important. So very, very, very important. So it's from 30 to 90 and from 150 to 270. So it means the other point, it is where G is bigger than F. So it means if we wanted to talk about where G is bigger than F, it will be from 0 to 30, and also from 90 to 150, and also from 270 to 360. It will also depend whether there's an equal sign or not. So that was the first question. Now, the second question, it says, determine the value of x for which, let me write the second one, for which x multiplied by g of x is greater than 0 or equals to 0, is greater or equals to 0. So when we say greater or equals to 0, it means we want this to be positive actually, because any number that is greater than 0 is actually positive. And how can this be positive? We have two ways. It's either x is positive or f is positive, or it's either x is negative or f is negative, because positive times positive will be positive, or negative times negative will be positive. So let us look on the graph. On the graph, let us look at the x-axis. Our x-axis is positive throughout. We do not have negative because we are sketching from 0 to 360. So it means we do not have this part. Why? Because the x is positive throughout, from 0 to 360 is positive. So it means you have to consider the upper one. And how are we going to do that? It means you're going to look for the value of x where x is positive, and at the same time, the graph of f is above the x-axis. So we want to identify a point where the graph of, where the x is positive And at the same time, when x is positive, the graph of f is above the x-axis, because if it's above the x-axis, it means it is where it is positive. Look at this, guys. We're talking about f. Let's identify that. From 0 to 90, the graph of f is above the x-axis. It's above the x-axis. So it means it is the point where it is actually positive. You see that at that time where f is above the x-axis, the x on its own is positive. It's positive throughout. So it means where the graph is greater than 0, or where x is positive and at the same time f is positive, the first one, because there's equals to, we're going to say it's from 0. It's from 0. That is the first one. It's from 0 to 30 to 90. I mean to say from 0 to 90. Y inclusive. From 0 to 90, f is positive because above the x-axis, even x is positive. But look, from 90 to maybe, let's say 180. From 9 to 180, x is positive, but the graph of f is negative, so it's not where we want. Right, from 180 to 270, the graph of f is actually positive. And at the same time, even the x is also positive. So it means you're going to include them and say from also from where? From 180 inclusive. From 180 inclusive up until 270. So it means these are the only answers, because this side x is positive, but g it's f is negative, so it's not what we want. So we got the answer. It's from 0 to 90 and from 180. Actually from 180, because not 150 but 180 here. From 180 up until 270. F is positive, but at the same time x is positive. So that is where we get our answer. Then 1.3, I believe now you are following, guys. 1.3, it says we want where f of x multiplied by g of x, the answer will be less than 0. Less than 0, which means we want the answer to be negative. Less than 0, it means we want the answer to be negative. And by the way, if we want the answer to be negative, it's either the what? It's either the f is what? It's positive. And at that time, the g is negative, because it means, or the f is negative, and at that time, the g is positive. What does this mean? It means we want where the graph of f is above the x-axis, because if it's above the x-axis, it's positive, or at the same time, g is below the x-axis. And or this side, it's either this one is below, and at the same time, g is above. Where is the point? So we're going to read from the graph. Let's check. Let us check where f is above, but g is below. From 0 to 90, both f and g are above, so it's not what we want. And from 90 to exactly 180 here, from 90 to exactly 180, g is below the x-axis, even f is, it means they're both negative. It's not what we want. So it's actually the opposite of the first one, actually. All right, then now it means we're going to check. Look from 180. From 180 up until, let's say up until 270, you see that one is positive and the other one is negative. Same applies even from 270 to 360. One is positive and the other one is negative. But now we have to, because there's no equal sign here, we have to exclude where they are actually equal. So we can do it like this. We can say, we can write the answer in two ways. We can either say from open brackets, not including, from 180, not including, from 180 to what? From 180 to 270, open brackets, or from 270 to actually 360 degrees, 360 degrees. But now look at this, guys. There's something at 180, or at 180, and this is the point where this one is 0. It's not above. It's just okay. It's fine. It's 0 actually. So it means you're going to say from 180 to 270, or from 270 to 180 to 360. Or if you don't want to do that, we can say straight from 180, from 180 straight to 270. But we have to exclude only one value. No, to 360. I apologize. From 180 straight to 360 up until here, but we have to include x must not be equals to 270 degrees. So we're excluding this where they're actually equal. Remember, you can either use in terms of x values, so it's also fine. It is also fine. So it's where the one graph is above and the other one is below. One graph is above the x-axis and one other one is below the x-axis, because they're both, one should be positive, one should be negative, so such that when we multiply their sign, then the answer becomes less than 0. I believe you guys are following. Right. So now I want us to move on to the next question. So below the x-axis and above the x-axis. I hope you guys are following. Okay, then the other question, remember this for both grade 11 and 12. Then 1 point, is it 1.4? 1.4, it says, no, it's, by the way, this was 1.8, but it's fine. Let's just call it 1.4 because already we used that. So now 1.4, it says, now we have to determine this for grade 12 only. F of x multiplied by g prime x. This is greater or equals to 0. This is greater or equals to, okay, I apologize, guys, just a minute. Okay, now we want where f times g of x by the g prime. This represents the gradient. Here we're talking about the gradient of a function. Remember in calculus. So what does it mean? Because it says greater than 0, it means you want where there's plus. So it means they're either both positive, or both negative. But in the context of this one for the gradient, where the gradient is positive, it means we want where the graph is increasing actually. And when the gradient is negative, we want where the graph is actually decreasing. But in this time, because it's just a function, we want where it's above the x-axis. Here it's below the x-axis. Let's first check with the gradient. Let's first analyze the gradient of G. Let me use, I don't know which color can I use here so that everyone can be able to see. Which color is relevant here? Okay, let's just use this one. Look, for G, here, throughout this point here, the graph is actually decreasing. It's decreasing here, the graph is decreasing. Its graph is negative. But here, the graph is not increasing and decreasing because the graph it's constant. Its gradient is 0. So this side, the graph is increasing. Right. So what does the question says? It says we need to first look at where f is above the x-axis. And at that time, the graph must be increasing. So let's check where the f is above the x-axis while the graph is increasing. Where is the graph increasing? The graph is increasing from here to this side. So now, this is for G, right? It's increasing. But at this point, where do we have the graph increasing and at the same time, f is above the x-axis? It's from here up until here. It's from 180 up until 270 because the graph of f is above the x-axis. And at that time, it means it's positive. At that time, the graph of G is increasing. So it means now the first answer will be, okay, we'll consider from 180 to 270. Let's go and check another one. Another one, it's where we want where it is actually decreasing. But at that time when it's decreasing, the f must be below. Where is that point? Obvious, it's from here. Here is decreasing, from 90 is decreasing. And at that time when it's decreasing, the f is what? Is below the x-axis up until here. So you see that is below the x-axis. So it means actually the answer is from here up until here. But we need to exclude one value here, 180. Why 180? The graph at 180 is not increasing or decreasing. So it means you're going to say the answer is from, we can just write as an interval from 90, excluding or including 90 because it's either greater or equals to 0. So we're going to include that point there. So this will be from 90, it's inclusive there. From 90 2, we can do it in 2 ways, from 90 to 180, excluding 180, because at 180 the graph is not increasing or decreasing, or from 180 to, what is the highest point? 270 degrees. So we can say from 90 to 180, or even 270 degrees is also included. So we must put a close bracket for 270 because they're actually equal there. Okay, so now it means, or we can say, like, we can say from 90 straight to 270 degrees inclusive, but x should not be equals to 180. X should not be equals to 180. Okay, because at 180 the graph is not increasing and it's not decreasing. So it means you either write it like this or like that. So this is what you need to know. Then the last one, it's actually it's 1.8.5, which says, let's just call it 1.5, which says f of x multiplied by g of x. This is greater or equals to 0. We want this to be positive. And how can we want this to be positive? It means you see that f is positive, and at the same time g is positive. Or f is negative, at the same time g is negative. And what do you mean by positive? We're saying we want it to be above the x-axis. It means we want when they're both above the x-axis or when they're both below the x-axis. So it means this is the value of x where we want either they're both above or both below. And where is that point? Obvious, from 0 to 90, both graphs are above the x-axis. It means they're both positive. And from 90 to 150, okay, actually from 90 to 180, not 150, both below, this graph are both below the x-axis. So, but above that, one is above, one is below, one is not. So it means the answer is from let's say, we're including where they're actually equal. So we can say from what? From 0 to what? To 180 degrees inclusive. So from 0 to 180 degrees. So inclusive. So it's either they're both positive or both negative. So they are negative, both of them, from 0 to 180. There's no restriction here. From 0 to, because it's, from 0 to 180, or you can just say x is between 0 and 180 degrees. So this is what you need to understand, because we cannot say from 0 to 150, because at 150 they're equal, but above that still they're both negative. So it means that is what we want. Either they're both below the x-axis or both above the x-axis. So it's very important to know that. I believe, guys, you have enjoyed the session, and this is the end of the session. And kindly subscribe, like, and don't forget to hit the bell button for future video notification. Thank you very much. Enjoy your day. Bye-bye.